Right, grade 12s, let's have a look and revise the idea of a vertical shift. And I want to focus on two types of graphs. Number A, let's have a look at an example. If we took, say, hx was equal to, let's make it sine x plus 2. Alright, and what we want to do is we want to have a look at this graph, and then I want to go from, say, minus 90 to 360 as I've done in the diagram, and let's see how this graph works. Now this is a very simple graph. The basic sine curve, if you think about it, goes there, 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 and there. That was sine. Okay, no problem with sine. Now, what is going to happen? Now, unlike having 2 sine x, when you add 2, it's like all the other graphs that you deal with. You're simply going to lift those points by 2. So in other words, that point goes up to there. This one lifts to 2. So sine of 90 is 1 plus 2 is 3. Lifts up there. 180 lifts up to there. 270, that point there lifts up to there and over here. So your sine curve is simply going to jump up. It's not going to be a stretch like an amplitude shift, or in fact, as we're going to look at, as a period shift, but it's just moving up. And of course, it can go here if you actually move it from there to there. Remember, your sine curve did that. So it simply shifts up. Okay, now what is the maximum value for this blue graph? Is 3. The minimum is 1. So the range is 1 to 3. The period is still 360 degrees, and the amplitude is still 1. Remember, the amplitude is always the number there. It's really the half the distance between the maximum and the minimum. So if you look at those distances there, that distance is 2. So halve that and you get 1. So again, be careful with that maximum, minimum, range, and all those things. Okay, how about another graph? What if we tried px is equal to, let's say, the cos of x, the cos graph, and we subtract 3 for the same restriction. Let's have a look here. Well, where's the basic cos curve? There, 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 and there. Okay, so we draw our little basic cos curve in. And there we go. And simply all these critical points are now going to drop. They're going to simply drop 3. So that goes 1, 2, 3 to negative 2 there. This drops from there, goes 1, 2, 3. This point goes 1, 2, 3 there. This one goes 1, 2, 3 to there. And this goes 1, 2, 3. So what happens is your cos graph doesn't change its shape. There's no stretch involved like in an amplitude. It goes up there. And so we go, and we can also extend it to, if that goes down there, it's 1, 2, 3, it can go to there if you want to extend it. Now remember, your maximum value here is negative 2, and your minimum is negative 4, and the range is from negative 4 all the way up to negative 2. So it's the smallest to the biggest there. Your amplitude is still 1, that's your amplitude, and of course the minimum value is at negative 4 here. Okay, so it's simply the cos graph dropped down by 3. Remember, if you put a 3 next to cos, that would be 3 cos. That's an amplitude shift. Okay, I think we need to go through the period shifts from grade 11. Let's have a look at those. Okay, now period shifts, people. What happens now is that if you look at the graph of sine 2x, okay, if you remember this from grade 11, the 2's now inside there, it's next to the x. And what you do is you take the period of the sine graph 360 and you divide by that 2, which of course gives you 180. So what in essence is going to happen when you look at the sine curve, okay, which is over here, that sine graph, it normally does this. There we go. But now what's going to happen with a sine curve with these points? Something very interesting is going to happen. There's a period shift. So the period has got to go to 180. Now what I do, and then this is something that works very cool for me, I simply say, okay, if I look at my divisions, okay, my little divisions, now I'll explain to you what the divisions mean in a moment. I'm going to take the 180 degrees and divide it into 4 parts, which of course is going to give me 45. Okay, now what happens is that instead of going 0, 90, 180, 270, 360, we halve those. So 45 90 is going to be 45. So that point shifts to there. Okay. The 180, if you divide it by 2, shifts to 90. So what is happening is that your sine graph looks like that. The 270 divided by 2 gives you 135, and 360 gives you that. Now have a look at this. The cos curve is actually now, this cos has got, the blue graph's got a period of 180 degrees. Okay, so it's a period shift, and this graph can then keep repeating itself. It goes like that, that, and that. Okay, so it goes up there, down we go, and off we go. And that's the period shift for a graph. It's always about the number being inside there. Okay, now if you have a look at another one, let's say for example, okay, so let's have a look at the graph of, let's say we took y is equal to the cos of 3x. Well, what is the period? The period of cos is 360. So if we divide by 3, we get 120. Okay, now what would the divisions be? If you take 120 and you always divide it into 4, because remember you go from 0 to 90, that's like quadrant 1, quadrant 2, 3, 4, 0 to 90, 90 to 180, 180 to 270, 270 to 360. So if you divide by 4, you're going to be getting 30 degrees. Okay, 30 degrees there. Okay, now what I could do is I'm going to look at my basic cos curve, which is there. Cos normally does this. Let's just bring that down a little bit there. 90, 180, 270, and 360. So that's your basic cos curve. Okay, so the cos curve does this, and what we're going to be doing then, if we look at that carefully, what we're going to be doing is we're going to go, in other words, that naught stays. 90 divided by 3 is 30, so it goes there. So it comes down. Then go to 180 divided by 3 gives you 60. 270 divided by 3 is 90. And 360 divided by 3 is 120. Now look at that. The period, the graph actually kind of squashes into that kind of period there. Look at that. Into a period of 120. And this is the graph of cos 3x. You see, it's the graph of cos x squashed into a period of 120. And you can keep it going now. You can go down to there, just follows the pattern. You just follow the pattern to 240, 120 plus 120 is 240, 240 plus 120 is 360. So it goes again like this if you were going from 0 to 360. And there we have it. What a pleasure. Okay, and remember the period changes. Your amplitude is still 1 because that's half the distance between the minimum and the maximum. Your range is still -1 to 1, but the period is going to be quite interesting in this case. Okay, so be very careful with these graphs, okay, with the difference between period shifts and amplitude shifts. And I think that's what we really need to practice